Yeah, welcome back to AWS DevOps Logistic YouTube channel. Yeah, so thank you guys. Thanks for sharing all my videos and liking and subscribing. I don't want to force anybody to do all these things like and share and subscribe. That's okay. That's completely up to you. Anyways, just I'm just reminding you guys. Um, so today we are going to discuss about Kubernetes storage. So let's get into topic. Let me share my screen. Are you able to see my screen? Is it visible?
Yes. Yeah, sir, it's visible.
That's great. Yeah. Okay. I think why. Okay. All right. Yeah. So in this class, so we will explore various storage related concepts such as persistent volumes. Okay. So persistent volumes we have discussed already in Docker. So persistent volumes also access modes and how to configure the applications with the persistent storage. There are many different storage options available. Yes, and depending on your environment, choices maybe varies. Okay. However, covering of all those options in beyond
Sir,
the scope of the course. Yes, is it clear?
hello, sir.
Yeah, yeah. Yogesh, can you
No,
hear
sir,
me?
it's not clear.
It's not clear.
Yeah, now it's fine, sir. But at the time when you are explaining, that was not clear.
Hmm. Okay, some network issue is going on. Okay, I'll do one thing. If it is really that much issue, so is it fine right now? Is it fine?
No, sir, it's not audible.
One second, I'm changing the network. Guys, can you hear me now?
Yes, sir, it's clear now.
Okay, okay, that's fine. Okay, so yes, so we are focusing on the Kubernetes side of storage. So once you understand that, we'll be applying the knowledge, implement third-party storage solutions we'll see what are the third-party storages. And to understand this storage Kubernetes, the other container orchestration tools, it's important to first understand how to storage works with the containers in general. So understanding how storage works with the Docker and getting the basics right, it will be much easier to grasp Kubernetes storage. So mainly, if you have a little bit, at least if you can recollect the knowledge from the Docker classes, so then it is easy to understand. Okay, the Kubernetes. That's why I already mentioned many times while I'm teaching Docker. So this will be correlated, Docker and Kubernetes. Okay. So yeah, so when it comes to the Docker storage, there are two key components to be aware of. Okay, storage drivers and volume driver plugins. Okay, so this is something we have covered in the Docker course. So if you are familiar with it, feel free to better just so we will just rewind, just recollect whatever we had discussed earlier. Okay. So let's move. Okay. Storage in Kubernetes. To understand the storage container orchestration tools like Kubernetes, it's essential to first to grasp how storage works with the Kubernetes, practically with the Docker. So getting the basics right in the Docker will make it much easier to understand how storage functions in the Kubernetes. When it comes to storage in Docker, there are two key concepts you need to know. One is actually storage driver, and the other one is volume driver. These two. In the up, maybe next, if you are already gone through that, that's fine. But just try to watch my videos if you don't. Maybe if you don't recollect all these things. So just now, just we are going to learn about advanced whatever Docker concepts. In this, maybe in this session, we will discuss Docker storage and Docker storage drivers in file systems like this. This already I have. It is in the screen. So well, actually, we will explore where and how Docker stores data, as well as how it manages the file system in containers. Let's check. So I hope this you can see, guys, right? So this is actually some file system. So basically in the Windows you can see all these things, right? This directory structure. Okay. So in this structure contains multiple folders including this a something AUFS, containers, image, volumes. Okay. This is where Kubernetes store in the data, which means var library Docker. Okay. So by the data, so by the data I mean files related to image and containers running on the Docker host. For example, all files related to the containers are stored in the containers folder, while files related to the images are stored in the images folder. Files, if it is related to images, it will store in the images folder. Okay, volume, if it is related to volumes will store in the volumes folder. These are all directory under this where library Docker. This is a directory. Okay, so any volumes created by Docker containers are stored in the volume folder. Okay, so we will come back it shortly. For now, let's just understand where Docker stores. Just simply how files and what format. Okay, like this. Okay, so how exactly does Kubernetes store files, an image and container? To understand that, we need to grasp Docker layered structure. This one. Okay, this is layered structure.
Sir,
Okay, yeah.
sir, I think it's not audible.
I think some was actually rain came right last
Hi,
night.
Shondro. Is it audible for you?
Last night actually it's too much rainfall in Hyderabad. I don't know. Maybe network
Okay, okay.
fluctuation. Too much fluctuation. So what should we do? So I'll do one thing. Try to understand. I'll share this video as soon as possible. Then maybe I'm recording, right, guys? Are you able to hear me?
Yes, sir, it's fine now, but when you are explaining, it is
Sometimes,
getting.
okay. Sometimes.
Hello,
Yes,
sometimes it's fluctuating, sir.
Mm,
Like network is lag.
yeah, network is like why? Because too much rainfall last night. Maybe that might be the reason. I think so. Let's see. Hmm. Wait. Just give me 1 second. I'll try to refresh this. I'll try to connect with other one. Is it audible now?
You know, it's clear,
yes, sir.
sir.
Now it's clear.
After
Okay,
5 minutes or 10 minutes, it's like same.
maybe it's varying, I think so. Okay, fine. So try to understand,
Yes, yes.
else next class I will repeat again then. Okay. So so this is structure contain multiple folders including so all these things, and now I'm just showing this layered architecture. Okay, what happened guys? Is it clear or not?
Not audible. No, sir, not audible.
Just give me 1 second, I can try to
If
I'll
your
repeat.
voice,
Just give me 1 second. Maybe some network issue, I think so. Guys, is this fine now? Anyone response?
yes, sir.
This is fine now. Is it clear now?
Yes, sir, it's fine.
Yes, sir.
Yeah, yeah.
Yeah, now it's clear, sir.
Yeah, this is actually Docker layered structure. um, so this layer structure, if you can understand, so let's just check once. When Docker builds images, it does so in layer architecture. So Docker file we will write like this. Okay, from Ubuntu run command using so package, this packages will run the whatever the packages we need. So copy so and so file, so encrypt the format, so like this. So for example, the base layer is a Ubuntu, correct? This is base layer. So if you can see the steps, okay, base layer is Ubuntu. So for so next layer is installs to additional packages, and another layer adds Python package, followed by layer that copies over the source code. So and finally layer that updates the entry point of the image. Okay, so layer only stores the changes from the previous layer. This affects the overall size. If you look, so this Ubuntu image, it is around 20 megabytes in size. Sorry, 120, right? This is 20 or 120. Okay, megabytes in size. While the additional package is installed, maybe amount to be maybe increased, something like this. Okay, whenever it is adds, the size will be increasing. Okay, 300, something like this. Okay, so the remaining layers being relatively small compared to this. Whenever packages is running, so it will be increase, so remaining all normally. So encrypt maybe it is less only, right? So that is also to understand that advantages of the layers architecture. It's considered a second application. Okay, the application has different Docker file, but it is quite similar to our first application. So in that it uses the same base image and the same Python dependencies. So if you compare this two, this is this actually I've taken one image. So this is actually Docker file, this is Docker file 2. I'm just trying to compare. Okay, so if you compare this, if you see the packages, first from Ubuntu base machine, run the packages, whatever the packages Python related, copy. So all the same, right? So this is actually first 120 MB. When I run the Docker build command to create a new image, for this application Docker will reuse the first three layers from the cache, because they are same as those built for the first application. it will only create the last two layers with a new source code and entry point. This approach allows you Docker to build image faster and save the disk space. Okay, this is also applies if you update your application code. So whenever you are update your application code, for example app.py, Docker will reuse all the previous layers from the cache and quickly rebuild the application image with the latest source code, significantly speeding up your process. Okay, to better visualize the layers, let's arrange them and from bottom to top. So I'll try to this. So this is for example to better understand, so we can understand this. So actually top to bottom, but we'll keep it one by one. So like first one is Ubuntu layer. Okay, so so Ubuntu layer followed by the packages, then the dependencies, the application source code, and finally entry point. All of these layers are created when we use, so when we run the Docker build. Okay, to form the final Docker image. Okay, once the build is complete, you cannot modify the content of these layers. They are only read only. Okay, and can only be changed initiating new build. When you run the container based on this image using the Docker run command, Docker creates the container from these layers and adds a new variable layer on top. Okay, like this container layer, right? So so when the container is destroyed, this layer, all the changes stored in it are also removed. Remember that the same image layer is shared by all the containers created from this image. If I were to enter newly created container and created new file called so and so example temp dot txt like that, it would be stored in the containers writable layer. Okay, so the image layer being read only means that cannot edit anything in this layers directly. So now regarding our application code, since we include our code is in the image, it becomes a part of the image layer and it is read only. Okay, after running the container. Okay, so if I want to modify the source code to test the changes, I can still do so. Before saving the modified file, Docker automatically creates a copy of the file in the writable layer. So meaning I'll be editing a different version of this file there. So in future, all future modifications will occur in this copy the writable layer mechanism, so known as copy on write. Okay, so read only nature of the image layer ensures that the files in these layers remain the unchanged unless you rebuild the image using the Docker build command. So okay, what happens when you remove the container, all the data stored in the container layer will be also deleted. This includes any changes made app.py and the new temp.txt file so will be created. If we want to persist this data instance, for instance, okay, if we are working as a database, so we can add persistent volume into the container. Okay, to do this, first we create volume. Okay, using the command. So what is that command? Okay, volume name, this is a command docker volume create so and so. Okay, it creates the folder called data volume, this data volume. Okay, and under docker for volumes directory only. Okay, this is for example this is ls something. If you see list variable libraries docker volumes. Okay, so if you see you can get like this. So next, docker volume ls, if you see, you will get the data like this. Docker run -v data volumes. So this is actually volumes. This command will create a new container and mount the data underscore volume we created into mysql folder in this, inside the container, ensuring all data when by written by um, database is stored on the volume created on the docker host. Even if the container is destroyed, the data will still persist. Okay, when if what if you run the docker run command, so to create new instance of the mysql container, the volume named data volume 2, this one. Okay, so in this hasn't been created yet, so nothing we have created here. Docker will automatically create a volume named dot data underscore volume 2 and mount it container something. Okay, you can view all these volumes by listing, so ls where library docker and so volumes folder. This process is known as volume mounting. So this is how we used to use volume because just I am just copied all the data, I'm trying to explain you guys. But in docker, so we have created all volumes one by one. I am not creating anything here, just I'm reminding. So we are collecting the information from the docker volumes. Guys, I have already explained, you know that, Ashwin, right? Maybe this is the
Yes.
different example, but we have created volumes in the docker. So if you don't remember, go and try to watch and recollect the information, because it will be useful for your upcoming storage classes in the Kubernetes. Okay, so this is what we have. We can create like this docker run hyphen v verbose. So I can make it extend to run the command. So docker run hyphen v dot data volume. So this is the place. Okay. So this is a directory, and it will, in this directory we can create as a folder mysql something like this. So run the data volume 2. Okay. Run hyphen v verba data related. So docker run mount. So this is the command. Wait, I'll tell you. So for example, previous command we can written we can be written in using the hyphen mount options as like where is that, this one. Okay, okay, so here if you see this command, okay, so who is responsible for handling all these operations means maintaining the layered architecture, creating the writable layer, moving file across the layers, so enabling copyright. So that it would be store drivers, it's a drivers. So docker uses the storage drivers to facilitate the layer architecture. Some common storage drivers include the, so I have shown some starting like this one, AUFS, containers, image, volumes, so all these things. So overlay and overlay 2, the choice of storage drivers depends on the underlying operating system. So just I'm trying to rekind all these things. The common storage drivers are like these things: AUFS, ZFS. So this mappers overlay and overlay 2. Docker automatically select the best available storage driver based on operating system. Different storage drivers provide varying the performance and stability characteristics. So you may want to choose one of the aligns so with needs your application and organization. So if you would like to read more about any of these storage drivers, please just these are all docker official links. Okay, I have copied from docker. So if you go through this, you can clearly you can understand what is exactly storage. See, docker, this is a completely official docker documentation. So better go and try to read all these things, try to understand. Okay, so this So what is exactly volume driver plugin in Docker? So as we discussed, storage drivers which help manage storage for the images and containers, correct? So we also briefly touched like what is volumes. Okay, so if you want to persist storage, you need to create the volumes, correct? So remember that volumes are not managed by the storage drivers, they are handled by volume driver plugins. Okay, so the default volume driver plugin is local, which creates a local volume on the Docker host and store its data under Docker library, Docker volumes directly. I have mentioned here, but here I did not mention this one. Okay, so Docker host to store data under, so and so this blindly you just remind guys, it will store whatever the volumes. Okay, where library Docker volumes. Okay, so there are many other volume drivers plugins that allows you to create the volumes on the third party solutions such as Azure file storage. Okay, um, Cano is something. DigitalOcean, you know, guys, you know DigitalOcean, right?
Yes, sir.
DigitalOcean is also one cloud platform. Okay,
Cloud. Yes.
yeah, something like AWS. Okay, so and that is actually named called DigitalOcean is cloud platform, but volume storage related DigitalOcean block storage. Okay, next one is what is this? Portworx. Okay, next Google Compute Persistent Disk also, Cluster FS also, net. So some NetApp will be there. Portvax already I mentioned, and VMware, vSphere. So there are a lot of third-party tools are available. Okay, so volume driver supports. So these are all. It will support volume drivers. Okay, so the Rexray the Rexray storage driver can provision storage AWS, EBS, S3, EMC storage. Okay, so like Scale IO, Google Persistent Disk, or OpenStack, like Signed or something. So when you run a Docker container, you can specify a particular volume driver such as Rexray or EBS to provision volume from the Amazon EBS. This setups create a container and attaches the volume for the from the AWS cloud. When the container exists, your data remains saved in the cloud. You understood?
Yes, sir.
So this, for example, if it is AWS EBS, so Docker run -it name MySQL so and so. So if you run this particularly, if you mention that, that will be stored in AWS EBS. Okay. So whenever you exit, your data remains will be stored in the cloud. Correct. So container actually we have done all these things right in Docker. So container
Yes, sir.
storage interface RKT we have discussed, and RKT means rocket, you know that, right? So Docker Creo, so we have installed Creo also, correct? So before going to the corps management, we also tried with Creo, right? So in the Kubernetes also as a prerequisite.
Yes, sir.
So in the past, Kubernetes used Docker extensively as its container run engine, right? And the code to work with Docker was embedded with the Kubernetes resource code. So with the introduction of the container runtime such as RKT means Rocket, okay, and Creo becomes essential to open up extend support for the multiple container runtimes. Okay, reducing the dependency on the Kubernetes code base. So it lead the development of the container runtime interface. which means CRIO. Okay, so the CRIO is standard that defines how the orchestration solutions like Kubernetes communicates with the container runtimes like Docker. In the future also, if any new container runtime is developed, it can simply follow the CRIO standards. That's why last time we have mentioned, we have discussed in the Kubernetes starting also, CRIO is advanced one. Okay, even if it is upgraded also, CRIO can able to take that standards, allowing it up to allowing to work with the Kubernetes without needing collaborate the directly with the Kubernetes development team. So as we discussed networking lectures, so the container networking interface was introduced extend support for the different networking solutions. This allows new networking vendors develop their plugins to container networking standards. So the container storage interface was developed to support multiple storage solutions. Okay, like CSI, this one. Okay, so you can write your own drivers to work with Kubernetes storage. So some numerous vendors have their own CSI drivers, including AWS EBS, Azure Disk, Dell EMC, okay, PowerMax Unity, Extreme IO. So this cluster FS, maybe I can make it bigger one, so you can read now. So Waveworks, okay, Hitachi also have their own CSA drivers. It's important to note that CSA is not specific to Kubernetes. CSA is not specific to Kubernetes. It is universal standard. When implemented, it allows any container orchestration tool to work with any storage vendor that has supported plugin. Okay, currently Kubernetes, Cloud Foundry, and Mesos are all on board with the CSA. Okay, so uh, so it defines a set of remote procedure calls RPC. Okay, that RPC. One second. Okay, it defines a set of RPC or remote procedure calls container orchestrator. Okay, so this is just for knowledge purpose I'm telling, guys. No worries about all these things, don't worry. Okay, so and this must be implemented by the storage drivers. For example, when a pod is created the requires volumes, orchestrators should call the create RPC and pass set of all details such as volume name. The driver, for example, the storage driver must be implemented this RPC, handle the request provision a new volume on the storage array, and return the results of the operation. Okay, so similarly, when the volume is to be deleted, the orchestrator should call the delete volume, which is RPC, and storage driver should handle the decommissioning of the volume from the array. The CSI specification details exactly parameters should send to be by caller, and error codes that should be exchanged. Okay, so just this is like kind of information, guys. This is, we have not that much digged into that Kubernetes storage. These are all just I got some resource and there it found, I just copied here and tried collect information. The same only I'm trying to explaining you guys. Better you try to go with these documents, once official documents for the storage, Docker storage, you will get somewhat information about from there. No, not somewhat, you will get more information. So before going to this Kubernetes, I just remind all these things. Don't worry, even if you don't get it, that's not a big deal. So before going to this, just I recommended, just want to just walk through all these things. Anyways, next we will discuss about volumes, not now. So next class, maybe second half, we'll connect again. So let's discuss all these things. We'll discuss one by one. So how to create the volumes and how to mount it. Okay, so guys, you know the terminology is mounting. So Yashwant, I only ask you because Yogesh was available at the time. He was not there. So we
Yes, sir.
were mounted, right? So in AWS we have
Yeah, yeah.
mounted. You know that? What is the difference? What is mounting?
Yes, sir.
What is mounting?
Like external volumes we were attaching, sir,
Exactly. Good.
with the internal one.
Exactly. Whatever the existed one, so we have detached and extra we have created, and that we have mounted with the eh, current one, right? So we just extra we have created one volume that we are mounting with the database. So whatever, sorry, database, not database, volume. We are attaching it, right, in the storage. So which means we are attaching, which means we are external, whatever the volume which we have created, we are just simply attaching with the existed one. So we
Yes,
are,
sir.
that is called as mounting. That's I'm telling, why I'm telling, in the sense this is for terminology. Terminology is most important, guys, because it will makes you more confused in the interviews. Okay, this terminology always they will try to confuse you. So terminologies are important. Do focus on terminologies. Don't forget the terminologies. If you know the terminologies, definitely you will get the answer for sure. Right?
Yes, sir.
So that's it, guys. Tomorrow, not tomorrow. Next class, we are going to discuss about the volumes, Kubernetes volumes. How, let's see how we have to write the um, manifest file. Okay, how we have to create the pod for the volumes. Okay, how to mount the volumes. This is what we will see. This is also object, guys. Try to understand. We are creating a pod, and also we are keeping extra instructions and extra fields related to volumes. Okay, so we will discuss all these things next class. Okay, you understood, guys? Don't worry about this today's class. So next class we'll connect, we'll see the volumes. Okay, that's
Yes,
it,
sir.
guys. Thank you so much. We'll connect next class. Until then, take care. Bye bye. There's Rami. What is this? What is this?